Part 2. Chapter 1. 3 Space. Genesis of a cube. Appearances of a cube to a plane being. The models consist of a set of 8 and a set of 4 cubes. They are marked with different colors, so as to show the properties of the figure in higher space, to which they belong. The simplest figure in one-dimensional space, that is, in a straight line, is a straight line bounded at the 2 extremities. The figure in this case consists of a length bounded by 2 points. Looking at cube 1, and placing it so that the figure 1 is uppermost, we notice a straight line in contact with the table, which is colored orange. It begins in a gold point and ends in a fawn point. The orange extends to some distance on 2 faces of the cube, but for our present purpose we suppose it to be simply a thin line. This line we conceive to be generated in the following way. Let a point move and trace out a line. Let the point be the gold point, and let it, moving, trace out the orange line and terminate in the fawn point. Thus the figure consists of the point at which it begins, the point at which it ends, and the portion between. We may suppose the point to start as a gold point, to change its color to orange during the motion, and when it stops to become fawn. The motion we suppose from left to right, and its direction we call x. If, now, this orange line move away from us at right angles, it will trace out a square. Let this be the black square, which is seen underneath Model 1. The points, which bound the line, will during this motion trace out lines, and to these lines there will be terminal points. Also, the square will be terminated by a line on the opposite side. Let the gold point in moving away trace out a blue line and end in a buff point, the fawn point a crimson line ending in a terracotta point. The orange line, having traced a black square, ends in a green-gray line. This direction, away from the observer, we call y. Now, let the whole black square traced out by the orange line move upwards at right angles. It will trace out a new figure, a cube. And the edges of the square, while moving upwards, will trace out squares. Bounding the cube, and opposite to the black square, will be another square. Let the orange line moving upwards trace a dark blue square and end in a reddish line. The gold point traces a brown line, the fawn point traces a French gray line, and these lines end in a light blue and a dull purple point. Let the blue line trace a vermilion square and end in a deep yellow line. Let the buff point trace a green line and end in a red point. The green-gray line traces a light yellow square and ends in a leaden line. The terracotta point traces a dark slate line and ends in a deep blue point. The crimson line traces a blue-green square and ends in a bright blue line. Finally, the black square traces a cube, the color of which is invisible, and ends in a white square. We suppose the color of the cube to be a light buff. The upward direction we call z. Thus we say, the gold point moved z, traces a brown line, and ends in a light blue point. We can now clearly realize and refer to each region of the cube by a color. At the gold point, lines from 3 directions meet, the x-line orange, the y-line blue, the z-line brown. Thus we began with a figure of 1 dimension, a line, we passed on to a figure of 2 dimensions, a square, and ended with a figure of 3 dimensions, a cube. The square represents a figure in 2 dimensions, but if we want to realize what it is to a being in 2 dimensions, we must not look down on it. Such a view could not be taken by a plane being. Let us suppose a being moving on the surface of the table and unable to rise from it. Let it not know that it is upon anything, but let it believe that the two directions and compounds of those two directions are all possible directions. Moreover, let it not ask the question, on what am I supported? Let it see no reason for any such question, but simply call the smooth surface, along which it moves, space. Such a being could not tell the color of the square traced by the orange line. The square would be bounded by the lines which surround it, and only by breaking through one of those lines could the plane being discover the color of the square. In trying to realize the experience of a plane being, it is best to suppose that its two dimensions are upwards and sideways, i.e., z and x, because, if there be any matter in the plane world, it will, like matter in the solid world, exert attractions and repulsions. The matter, like the beings, must be supposed very thin, that is, of so slight thickness that it is quite unnoticed by the being. Now, if there be a very large mass of such matter lying on the table, and a plane being be free to move about it, he will be attracted to it in every direction. Towards this huge mass would be down, and away from it would be up, just as towards the earth is to solid beings down, and away from it is up, at whatever part of the globe they may be. Hence, if we want to realize a plane being's feelings, we must keep the sense of up and down. Therefore we must use the z direction, ere it is more convenient to take z and x than z and y. Any direction lying between these is said to be compounded of the two, for, if we move slantwise for some distance, the point reached might have been also reached by going a certain distance x, and then a certain distance z, or vice versa. Let us suppose the orange line has moved z, and traced the dark blue square ending in the reddish line. If we now place a piece of stiff paper against the dark blue square, and suppose the plane beings to move to and fro on that surface of the paper, which touches the square, we shall have means of representing their experience. To obtain a more consistent view of their existence, let us suppose the piece of paper extended, so that it cuts through our earth and comes out at the antipodes, thus cutting the earth in two. Then suppose all the earth were moved away, both hemispheres vanishing, and only a very thin layer of matter left upon the paper on that side which touches the dark blue square. This represents what the world would be to a plane being. It is of some importance to get the notion of the directions in a plane world, as great difficulty arises from our notions of up and down. We miss the right analogy if we conceive of a plane world without the conception of up and down. A good plan is to use a slanting surface, a stiff card or book cover, so placed that it slopes upwards to the eye. Then gravity acts as two forces. It acts as a force pressing all particles upon the slanting surface into it, and as a force of gravity along the plane, making particles tend to slip down its incline. We may suppose that in a plane world there are two such forces, one keeping the beings thereon to the plane, the other acting between bodies in it, and of such a nature that by virtue of it any large mass of plane matter produces on small particles around it the same effects as the large mass of solid matter, called our earth, produces on small objects like our bodies situated around it. In both cases the larger draws the smaller to itself, and creates the sensations of up and down. If we hold the cube so that its dark blue side touches a sheet of paper held upwards to the eye, and if we then look straight down along the paper, confining our view to that which is in actual contact with the paper, we see the same view of the cube as a plane being would get. We see a light blue point, a reddish line, and a dull purple point. The plane being only sees a line, just as we only see a square of the cube. The line where the paper rests on the table may be taken as representative of the surface of the plane being's earth. It would be merely a line to him, but it would have the same property in relation to the plane world as a square has in relation to a solid world. In neither case can the notion of what in the latter is termed solidity be quite excluded. If the plane being broke through the line bounding his earth, he would find more matter beyond it. Let us now leave out of consideration the question of up and down in a plane world. Let us no longer consider it in the vertical, or zx, position, but simply take the surface, xy, of the table as that which supports a plane world. Let us represent its inhabitants by thin pieces of paper, which are free to move over the surface of the table, but cannot rise from it. Also, let the thickness, i.e., height above the surface, of these beings be so small that they cannot discern it. Lastly, let us premise there is no attraction in their world, so that they have not any up and down. Placing cubi in front of us, let us now ask how a plane being could apprehend such a cube. The black face he could easily study. He would find it bounded by gold point, orange line, fawn point, crimson line, and so on. And he would discover it was black by cutting through any of these lines and entering it. This operation would be equivalent to the mining of a solid being. But of what came above the black square he would be completely ignorant. Let us now suppose a square hole to be made in the table, so that the cube could pass through, and let the cube fit the opening so exactly that no trace of the cutting of the table be visible to the plane being. If the cube began to pass through, it would seem to him simply to change, for of its motion he could not be aware, as he would not know the direction in which it moved. Let it pass down till the white square be just on a level with the surface of the table. The plane being would then perceive a light blue point, a reddish line, a dull purple point, a bright blue line, and so on. These would surround a white square, which belonged to the same body as that to which the black square belonged. But in this body there would be a dimension, which was not in the square. Our upward direction would not be apprehended by him directly. Motion from above downwards would only be apprehended as a change in the figure before him. He would not say that he had before him different sections of a cube, but only a changing square. If he wanted to look at the upper square, he could only do so when the black square had gone an inch below his plane. To study the upper square simultaneously with the lower, he would have to make a model of it, and then he could place it beside the lower one. Looking at the cube, we see that the reddish line corresponds precisely to the orange line, and the deep yellow to the blue line. But if the plane being had a model of the upper square, and placed it on the right-hand side of the black square, the deep yellow line would come next to the crimson line of the black square. There would be a discontinuity about it. All that he could do would be to observe which part in the one square corresponded to which part in the other. Obviously, too, there lies something between the black square and the white. The plane being would notice that when a line moves in a direction not its own, it traces out a square. When the orange line is moved away, it traces out the black square. The conception of a new direction thus obtained, he would understand that the orange line moving so would trace out a square, and the blue line moving so would do the same. To us these squares are visible as holes, the dark blue, and the vermilion. To him they would be matters of verbal definition rather than ascertained facts. However, given that he had the experience of a cube being pushed through his plane, he would know there was some figure, whereof his square was part, which was bounded by his square on one side, and by a white square on another side. We have supposed him to make models of these boundaries, a black square and a white square. The black square, which is his solid matter, is only one boundary of a figure in higher space. But we can suppose the cube to be presented to him otherwise than by passing through his plane. It can be turned round the orange knee, in which case the blue line goes out, and, after a time, the brown line comes in. It must be noticed that the brown line comes into a direction opposite to that in which the blue line ran. These two lines are at right angles to each other, and, if one be moved upwards till it is at right angles to the surface of the table, the other comes onto the surface, but runs in a direction opposite to that in which the first ran. Thus, by turning the cube about the orange line and the blue line, different sides of it can be shown to a plane being. By combining the two processes of turning and pushing through the plane, all the sides can be shown to the plane being. For instance, if the cube be turned so that the dark blue square be on the plane, and it be then passed through, the light yellow square will come in. Now, if the plane being made a set of models of these different appearances and studied them, he could form some rational idea of the higher solid which produced them. He would become able to give some consistent account of the properties of this new kind of existence. He could say what came into his plane space, if the other space penetrated the plane edgewise or cornerwise, and could describe all that would come in as it turned about in any way. He would have 6 models. Let us consider 2 of them, the black and the white squares. We can observe them on the cube. Every color on the one is different from every color on the other. If we now ask what lies between the orange line and the reddish line, we know it is a square, for the orange line moving in any direction gives a square. And, if the 6 models were before the plane being, he could easily select that which showed what he wanted. For that which lies between orange line and reddish line must be bounded by orange and reddish lines. He would search among the 6 models lying beside each other on his plane, till he found the dark blue square. It is evident that only one other square differs in all its colors from the black square, viz., the white square. For it is entirely separate. The others meet it in one of their lines. This total difference exists in all the pairs of opposite surfaces on the cube. Now, suppose the plane being asked himself what would appear if the cube turned round the blue line. The cube would begin to pass through his space. The crimson line would disappear beneath the plane and the blue-green square would cut it, so that opposite to the blue line in the plane there would be a blue-green line. The French gray line and the dark slate line would be cut in points, and from the gold point to the French gray point would be a dark blue line. And opposite to it would be a light yellow line, from the buff point to the dark slate point. Thus the figure in the plane world would be an oblong instead of a square, and the interior of it would be of the same light buff color as the interior of the cube. It is assumed that the plane closes up round the passing cube, as the surface of a liquid does round any object immersed. But, in order to apprehend what would take place when this twisting round the blue line began, the plane being would have to set to work by parts. He has no conception of what a solid would do in twisting, but he knows what a plane does. Let him, then, instead of thinking of the whole black square, think only of the orange line. The dark blue square stands on it. As far as this square is concerned, twisting round the blue line is the same as twisting round the gold point. Let him imagine himself in that plane at right angles to his plane world, which contains the dark blue square. Let him keep his attention fixed on the line where the two planes meet, viz. that which is at first marked by the orange line. We will call this line the line of his plane, for all that he knows of his own plane is this line. Now, let the dark blue squares turn round the gold point. The orange line at once dips below the line of his plane, and the dark blue square passes through it. Therefore, in his plane he will see a dark blue line in place of the orange one. And in place of the fawn point, only further off from the gold point, will be a French gray point. The diagrams show how the cube appears as it is before and after the turning. G is the gold, F the fawn point. And G is unmoved, and the plane is cut by the French gray line, GF. Instead of imagining a direction he did not know, the plane being could think of the dark blue square as lying in his plane. But in this case the black square would be out off his plane, and only the orange line would remain in it. Diagram shows the dark blue square lying in his plane, and diagram shows it turning round the gold point. Here, instead of thinking about his plane and also that at right angles to it, he is only to think how the square turning round the gold point will cut the line, which runs left to right from G, viz., the dotted line. The French gray line is cut by the dotted line in a point. To find out what would come in at other parts, he need only treat a number of the plane sections of the cube perpendicular to the black square in the same manner as he had treated the dark blue square. Every such section would turn round a point, as the whole cube turned round the blue line. Thus he would treat the cube as a number of squares by taking parallel sections from the dark blue to the light yellow square, and he would turn each of these round a corner of the same color as the blue line. Combining these series of appearances, he would discover what came into his plane as the cube turned round the blue line. Thus, the problem of the turning of the cube could be settled by the consideration of the turnings of a number of squares. As the cube turned, a number of different appearances would be presented to the planed being. The black square would change into a light buff oblong, with dark blue, blue-green, light yellow, and blue sides, and would gradually elongate itself until it became as long as the diagonal of the square side of the cube, and then the bounding line opposite to the blue line would change from blue-green to bright blue, the other lines remaining the same color. If the cube then turned still further, the bright blue line would become white, and the oblong would diminish in length. It would in time become a vermilion square, with a deep yellow line opposite to the blue line. It would then pass wholly below the plane, and only the blue line would remain. If the turning were continued till half a revolution had been accomplished, the black square would come in again. But now it would come up into the plane from underneath. It would appear as a black square exactly similar to the first, but the orange line, instead of running left to right from gold point, would run right to left. The square would be the same, only differently disposed with regard to the blue line. It would be the looking glass image of the first square. There would be a difference in respect of the lie of the particles of which it was composed. If the plane being could examine its thickness, he would find that particles which, in the first case, lay above others, now lay below them. But, if he were really a plane being, he would have no idea of thickness in his squares, and he would find them both quite identical. Only the one would be to the other as if it had been pulled through itself. In this phenomenon of symmetry, he would apprehend the difference of the lie of the line, which went in the, to him, unknown direction of up and down.